how does a science become a real science? Like one professor in undergrad told science, forensic science is not a real science, but it's huge now. So how do we know when a science is real?
So I go first.
Hmm.
So last night I did my research for once. You feel me? And I was like, at first I was just like in my head, like, well, that doesn't make any sense. Like all science is real science. But then I was thinking, but then you have these flat earthers, so
Uh-oh.
and they think they're doing science, but they're actually not. So I actually looked up what science is and what the key underpinnings are.
Mhm.
And so there are 9 things that science is, or main characteristics. One, objectivity. Two, it has to be verifiable. It has to be ethically neutral. It has to have systematic exploration, reliability, precision, accuracy, abstractness, and lastly, and I think this is the most important one, it has to have predictability, which means it can predict other things. And I think this is the most important one. Oh, I hear my echo.
That's me. Sorry.
So I remember back in the days, I had a discussion with somebody about science and being predictable, like being able to predict other things. I remember back in the days, I had a discussion there are a lot of examples out there of science, uh, scientists having a theory about something and then using that theory to say, well, if this is true, then we should be able to see this from observation. And late, like in the times that they said this, they didn't have the technology to see the things. But later on, when they had the technology, they were able to identify those things that they predicted. And to me, that shows the value of science right there.
What do you think about that science?
Yeah, I mean, definitely the research that that Mino did, it makes sense. Those things are the key characteristics that we have to look for whenever we're talking about any field of study and emphasizing that it's a science. Definitely in the field of forensic science, it's a little different because forensic science did not come out of some systematic inquiry into a particular topic. It really came out of people wanting to figure out how to solve very specific issues being who did these crimes or who was responsible for, robbing this bank, who
Mm.
was responsible for, you know, stealing this money. These kinds of very specific things and looking at what people left behind, really. So forensic science wasn't birthed as a real science, if being completely honest, because it was never really an objective study in the very beginning. In the very beginning, it was very much subjective in the way that there are these specific things that we believe the perpetrators of these crimes would have left behind. So we believe by studying these things that we're going to be able to identify the perpetrators of these actions. And that has continued for a long time, probably up to today. But with the birth of DNA analysis, forensic science was really forced to change. And I would say that DNA analysis is definitely the thing that made forensic science huge. Because, by studying biochemistry, humans were able to unlock the key to all life, at least for human life, the Human Genome Project. Once we had actual evidence of the code for the human genome, we found that there were areas that could be used to identify individuals. And that has been big because you could do statistics with that. You could do all sorts of different things. You could actually look at phenotypes now. We could look at people's DNA and try to figure out what age bracket they're in. We could look at people's DNA, try to figure out other characteristics like height, possibly even weight, things like eye color, hair color. We could figure out these things. And that's a very systematic inquiry that was done outside of the realm of criminal activity. So that has really changed science. In terms of knowing if forensic science is a real science, right now there's a lot of objective study going on. And everything is all about trying to be verifiable and trying to find precision and accuracy through statistics. So that's really what's going on now, is this big crucible of trying to take something that was once very subjective and make it as objective as possible. And I think that really is the key for all real sciences. Is like, it doesn't matter how you begin, but you could delve deep right now into any science and try your best to apply all these amazing principles that we know, you know, are necessary. You know, the ethical responsibility, the ability to be accurate, the ability to be verifiable, as in to know, you know, how often do people get it right? How often do people get it wrong? It can't just be, you know, it's 100% certainty all the time. There must be some level of understanding, you know, what is the level of uncertainty? What is the level of error? How often do errors occur? So, you know, you could do all these different studies right now on any any area that you're looking into, and that's what I believe will make it a real science.
You know, I like that you bring up predictability. I mean, not predictability, error, and being aware that there's never going to be 100% correct all the time, because I think that's one thing people don't understand about science. Most of the laymen, you know, for instance, with the COVID, with them talking about COVID and all this stuff, and they keep coming back with new information, new information. A lot of people who are laymen took that as, oh, we can't trust them, instead of, oh, they're actually holding themselves accountable and with new information telling us what's going on. So it's interesting because I think a lot of people don't actually realize that science is not like 100% always correct all the time. It's an updating of knowledge over time and with checks and balances to make sure that that knowledge is accurate. So that's a very good point that you brought up.
I don't even know where the disconnect would come from because when we learn about science in grade school or high school, they tell us that science is something that changes over time. Like it's not never going to be 100% true. That's why people always repeat studies, they test evidence that was there before because there's always something new coming about that will change the results of the experiment, unless it's like a law or something like that. So like I don't know where the disconnect comes from that to growing up believing that scientists should be always 100% accurate, never make any mistakes, never change anything. And I don't know how we can bring back the idea to let people know that, hey, science is not going to be saying it's going to rain today and it always rains. Because even meteorology is not 100% true. It could be a 100% chance of rain today and it never rains. But it's because of the way that they do the data that they have that number of 100%. So even if they say 100%, it could still be less than as well.
Well, definitely, there's a lot of variables. There's so many variables to everything that we study. You know, definitely in forensic science, you know, I look at something as simple as fingerprints. You know, we know for a fact that we're probably never gonna find two people that have the exact same patterns of fingerprints on the exact same finger on the exact same hand, because we understand very well how fingerprints develop and how the skin develops on the human body. What we don't know is, you know, how often are we going to get the one person who we're interested in to deposit, you know, the pattern of their fingerprint on a particular surface on a particular day, because there's so many things that changes. You know, inside your sweat, you know, definitely on the palms of your hands, sweat comes off, and when you touch different surfaces, you're leaving behind the pattern of the skin on your hands on these different surfaces. But that depends on so many different things. What if you're not sweating? What if you're sweating and your sweat is just a little bit more water than usual? You know, that could easily get wiped off. You know, sometimes in this sweat, what we look for are things like proteins, amino acids. You know, what if you're not depositing amino acids today? Or what if the sweat that's on your hand actually came from you wiping a different part of your body that doesn't have amino acid sweat in it? Then we wouldn't be able to detect those either. So there's a lot of different variables that we have to consider. I mean, forensic science, just thinking about fingerprints, you know, several different things, you know. Some people touch surfaces and then they leave smudges. Some people touch surfaces and they just pristinely lift up their hands and, you know, really nice pattern right there. But then somebody else comes along and rubs that surface. So, you know, what do? You know, some people touch surfaces more than once. So you get overlay of fingerprints. It's really, really difficult because you're not in control of all the variables. And when you start to study or do research, what you try and do is control the variables that you know about in order to see or test, you know, hypotheses. So these things are what we do in science, and you know, they're always going to be better studies, always will be, and there will always be more variables, and we probably will never know how many variables there are to any particular thing. Definitely for immunology, I'm looking at COVID-19. It's going to be several different variables. So I could see 1,000 years into the future, people are still studying the virus that causes COVID-19, and new information still coming to light about this time in history. So, I mean, maybe we should really be telling people that there's several different things that change and influence our results. And that's why things always change and results always change and advice changes and evidence changes in science.
Lee, you sure you're not a professor?
I just talk too much, man.
Nah, not too much. That was perfect. Go ahead, Wanted.
Oh, I was gonna say that was really good insight there. I'm really good. Every time we do this show, I'm always glad to have a guest on because they're always coming with their A game, and I know you would as well. So I'm really happy right now, even from the beginning, from the first question off the bat, we're already going good.
Yeah, y'all can't see me, but I nodding hard and I smiling big because yeah, I agree.
Now you look like you have a nice stern face on there, from what I could see.
You couldn't get me a picture with a smile or something. I mean, you just look good, very handsome man. But come on, man.
Oh man. Now this is a serious topic, so you need to be a little bit serious,
Yeah, vibe.